So welcome to lesson 4 of the trigonometric form 3 form 4 KCSE syllabus. In our fourth lesson, we are going to deal with trigonometric equations, and this just want to give you a brief description of trigonometric equations. They involve trigonometry ratios. This means we'll be dealing with sine, cosine, and tangent. That is equations formed from sine, cosine, and tangent. And you also realize that in many trigonometric equations, there are infinite number of roots. That is, a function can be, or an equation, trigonometric equations can be satisfied by many roots. For example, when we talk of sine x is equals to 0, x can also be 0, could be 180 plus or minus, could be plus or minus 360, could be 720 or minus 720. All this satisfies our equation x is equals to sine x is equals to 0. This means that when we are working with the trigonometric equations, we have to specify up to what range we want to our y to our x, or our value of the sine, cosine, or tangent to satisfy. That is why you find in trigonometric equations we have the range from 0 maybe less than or equals to x, less than or equals to 360. That means that the values that satisfy x should be in between 0 and 360. For example, if we say sine x is equals to 0, and we say it ranges from 0 to 360, then 720 is not included within that range. And therefore, those are the kind of equations that you'll be dealing with in this particular lesson. So let's have a look at an example and see how trigonometric equations are solved. So this is example 1. We are told to solve the trigonometric equations. Sine 2x is equals to cos x for the range 0 less than or equals to x less than or equals 360, like I have mentioned earlier. For when you are solving trigonometric equations, in most cases you will be given a certain range. So to be able to solve this, we say, okay, we are given that sine 2x is equals to cos x, but we know that cos x can be written as the sine of sine 90 degrees minus x. Those are, we call them complementary angles, and therefore we can replace our cos x with sine 90 minus x. So we can write sine 2x is equals to the sine of 90 minus x, 90 degrees. So we now have x sine on both sides. We can get the anti-logarithm sine of this, or rather we can remove sine and say our 2x is equals to 90 minus x. We bring x to this side. We have x is equals to, it will be 3x is equals to 90, and we divide both sides by 3. We divide by 3, you find that x is equals to 30 degrees. Now, the sine of 30, you did trigonometry in form 3, and we know that in the second quadrant, sine is positive. Hope you remember this. This is x. So sine in the second quadrant is also positive, and therefore we say that the sine of 100 and sine 30 is also equals to the sine of 150. So the other angle that satisfies our condition here is 350. We cannot take the third quadrant because sine is negative in this case, and also in the fourth quadrant. So those, we will not consider those angles. So these are the two angles that satisfy our equation, and that's how you work it out. Okay, our example 2, we are told to solve the following trigonometric equation for the range 0 degrees less than or equals to x degrees less than or equals to 360 degrees. Our equation is tan 3x is equals to 2. Now, the angle whose tangent is 2, if you use your calculator, is equals to, is equals to 63.43. Now, this angle here is in the first quadrant, and if we make our unit circle, okay, we have this is STC. So we also know that the angle in the third quadrant is also positive. So the angle in the second quadrant will be 63.43. You add 180. This is the angle that will come here. So that angle will be 243.43. So that's the second angle. Another angle is we add 180 to 243, and we will get 423.43. We add 180 to this angle, you get 603.43. We add 180 to this angle, you get 783.43, and we add 180 to this angle, you get 963.43. The reason why we are adding all these angles that goes beyond the 360 is because our angle here is 3x. Now this is, we are talking of one angle. So x, if this is 3x, it means our x is equals to, you divide 63.43 by 3, you get 21.14. You divide this angle 243 by 3, you get 81.14. You continue, you divide 423 by 3, you get 141.43. Not 43, but it is 0.14. You divide 603 by 3, you get 201.14. You divide the next angle, that is 783, and you get 261.14. And finally you divide our last angle, that is 963, you get, it is 321.14. So all these angles, you can see they are within our range, that is, they are not beyond 360. And that is why we say that trig ratios have infinite solutions or root, and therefore we need to define the range that we want to get our solution to our trig ratios. So let's look at another example. This is our example 3, and we are told to solve the following trigonometric equation for 2 sine into bracket x minus pi over 6 degrees is equals to minus root 3 for 0 radians less than or equals to x radians less than or equals to 2 pi. So this one, you can say this is, you can write it like this: sine x minus pi over 6 is equals to minus root of 3 divided by 2. We divide both sides by 2. Then from there, we say that the angle whose sine is 2 over 3 are 2 angles within 360, and these 2 angles are 240 and 300 degrees. 300 degrees. Now this is you realize that sine in our unit circle, sine is negative in the, so we have this is sine, we have that let's start act. So we have sine is negative in the 3rd quadrant and also in the 4th quadrant, and that is why we are talking of 240 and 300 degrees. So we now convert these angles to radian so that we are able to cover this range, and therefore we have 240. 240 is the same as, that is degrees, is the same as 4 over 3 pi radians, and 300 degrees is equals to 5 over 3 pi radians. So that is when you convert those 2 angles to radian, and therefore we now equate our expression here, that is x minus pi, we equate. So we have x minus pi over 6 is equals to, we start with this one is equals to 4 over 3 pi radians. So we take pi to the other side, pi over 6, so we have our x is equals to 4 over 3 pi radians. We add to pi over 6. So this will give us, when you add the 2, you get 9 over 6 pi radians, which is the same as 3 over 2 pi radians. So that's one angle. The other one, in terms of radians, the other one we equate x minus pi over 6 is equals to this one, that is 5 over 3 pi radians. You take the pi over 6 to the other side, you get our x is equals to 11 over 6 pi radians. So that's how we work it. We work out that question. So that's another trigonometric equation. So let's look at. So this is our example 4, and we are told to draw the graph of y is equals to sine 3x and y is equals cos 2 over 3x on the same axis for the range 0 less than 360 less than 0 less than x less than 360. Use your graph to determine the value of x for sine 3x is equals to cos 2 over 3x. So we are going to start by making our table that is going to help us to make the two graphs. So this is the table that we are going to use. We first fill the values of x. So I say that is 0. This is 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180, 210, then we have 240, then we have 270, we have 300, we have 330, and finally we have 360 degrees. Then we have y is equals to sine 3x. So when x is 0, this will be 0. Then we have 30, that is 90, it will be 1. This will be 0, and it keeps on repeating like that. Minus 1, 0, 1, 0, minus 1, 0, 1, 0, minus 1, and finally 0. Then we have y is equals cos 2 over 3x. This will give us, when x is 0, we get it is 1. Then we have 0.94. We have 0.77. Then we have 0.50. We have 0.17. We have minus 0.17. We have minus 0.50. We have minus 0.77. Then we have minus 0.94. From there we have minus 1. Then we have minus 0.94. We have minus 0.77, and finally we have minus 0.50. So that is a table that is going to assist us to plot the table. So now let's bring our graph paper so that we are able to plot this graph. So because of space, we only have our table and our graph paper. So we brought the two graphs. So let's say that is this is our starting point. So this is 0. Then we have that is 1, and that is 2. This is 2, and this is our y-axis. Then on the other side we have minus 1, and we have minus 2. Then here we have our points along the x-axis. So that is 30, we have 60, we have 90, we have 120, we have 150, we have 180, we have 210, then we have 240, we have 270, we have 300, 330, and 360. That is our x-axis. So from there, let us plot the first graph of y is equals to sine 3x. So we start by labeling the graph of y is equals sine 3x. So we start from 0, that is a point. Then we have 1, we have 0, we have 1, minus 1, then we have 0, we have 1 there, we have 0, we have minus 1, we have 0, we have 1, we have 0, we have 1, minus 1, we have we have 0 again. So we are going to join these points to come up with the graph of y is equals to sine 3x. So this is a graph of y is equals to 3 y is equals to sine 3x. You draw this graph using your free hand, and you remember to label your graph. So this is sine 3x, and from there we now move to the other function. We plot the graph of y is equals to cos 2 over 3x and see how it looks like. So this is the best I've come up with. The graph of y is equals to cos 2 over 3x. You can try and use a more expanded scale. That is why I had put 2 here, so that my scale, then I would have 1 at where the place of 2. But because I use that scale, maybe that would give you a better scale, which will enable you to draw a good graph. However, I have managed, but you should use that scale. So the question was, we drew the graph, which we have done, and on the same axis, and use a graph to determine the value of x for which the two functions are the same. And that is what we mean here is when sine 3x is equals to cos 2 over 3x. This means that we are looking at points where the two graphs cut each other. Those are the points. For example, we have here, that is 1 point. We have here, we have here. So you are required to read the values of angles at the point where the two graphs meet. And if you draw your graph correctly, then you should get the x is here, it's around 24, the first point, 24 degrees. Then we come to 36 degrees. Then we have this one, which is around 123 degrees. The other one is this one, around 198 degrees. The other one is this one, which is around 216. Then we have the next one is 318, and the last one is 354. So that is those are the values, the angle values where the two functions are equal, and that means the place where the two graphs cut each other. So this is another example, example 5. We are told to solve the equation sine into bracket 3x plus 30 degrees is equals to square root of 3 over 2. Okay, we can make a sketch here of a triangle to guide us, a right angle triangle, to guide us on how to go about it. So if this is our angle, then we can say this is root 3 and this is 2. This is the angle 3x plus 30 degrees. So we can say, if we use our calculator, we can get that the angle whose sine is root 3 over 2 is actually 60. So what this means is that the sine of 3x plus 30 degrees is the same as, put the bracket here, is the same as the sine of 60. So, and therefore 3x plus 30 degrees is equals to 60 degrees. We take that to the other side, then we have 3x is equals to, that will give us 30. We divide both sides by 3. We divide by 3 and we get our x is equals to 10 degrees. Now, if our x is 10 degrees, you can see here, when we multiply 3 times 10, that is 30 plus 30, that gives us 60, what we have here. Then, using our unit square, we can say that this is in the sign is positive in the second quadrant, and this means that the other angle that we can get is we can say it is 120. 120, the sine of 60 is the same as the sine of 120 in the second quadrant. Therefore, we can also equate 3x plus 30 is equals to 120, and we take that to the other side, we will get 3x is equals to 90. We divide both sides by 3, and we get our angle is, our x is also equals to 30. So this means that x is equals to 10 degrees, and it's also satisfy when we say it is 30 degrees, and that is how you work out that question. So this is our last example in this lesson, and we are required to solve this equation here, that 3 cos x is equals to 2 sine squared x. So for us to be able to do this, we need to have cos as common for both sides. So we know that we learned in trigonometry 3, in form 3, that cos squared theta, or let's use x instead of theta, so that it matches with what we have. So we have cos squared x plus sine squared x is equals to 1, and therefore if we take x to the other side, we have sine squared x is equals to 1 minus cos squared x. So we can actually replace our cosine squared here with this expression, and therefore we will write our equation as 3 cos x is equals to 2. Instead of cos squared, we write it is 1 minus cos squared x, not theta, x. So we open the bracket, so we have 3 cos x is equals to 2 minus 2 cos squared x. We can bring this side to the left hand side, and therefore this becomes positive. So we have 2 cos squared x, then we have plus 3 cos x, then we have 2 will change to minus, so in minus 2 is equals to 0. This is a quadratic expression, and we can let cos x is equals to y, so we can write this as 2y squared plus 3y minus 2 is equals to 0. Then we can factorize this, and we'll get 2y minus 1. When you factorize, I'm not going to do that, you have done that in the earlier course. So y plus 2 is equals to 0, and therefore we have y is equals to we can say y is equals to a half or minus 2. So if y is equals to a half or minus 2, this implies, since we had defined our y to be cos x, what it means is that cos x is equals to a half or minus 2. The angles that satisfy this condition one is angle 60. The cosine of angle 60 is a half. So we say x is equals to 60 degrees. And the other angle is 300. That is an angle in the fourth quadrant where cosine is negative. So it is 300 degrees. So these are the angles that satisfies our equation. And if you substitute here cosine of 60, that will give you cosine of 60 is a half multiplied by 3, that is 3/2. Then we have sine of 60. You check with your calculator, you find that it satisfies the equation that we have. So that brings us to the end of that lesson. Check for many questions that I'll be solving relating to trigonometric equations, so that you can understand and be comfortable to solve any question related to trigonometric equations. So welcome to other lessons. Check and you'll be able to find other lessons which are already existing, and many more that are going to come. So thank you for watching.